Symmetry is a quick little topic. One part of which is familiar since the olden times, and another part is maybe not so familiar. Basically, what you have is some sort of shape, and your job is to say how many axes or axes of symmetry it's got. So let's say this is your shape. I think that's got two axes of symmetry. There's this one. There's also this one. You do have to be careful. It's quite tempting when you see a parallelogram or a trapezium or whatever to think that this is an axis of symmetry. Now that has some appeal, but it's not correct. For something to be an axis of symmetry, you have to imagine for every single point that if you went straight to your proposed line of symmetry, and by straight there I mean when you get to it you hit it at a right angle, and went the same distance on the other side, you would need to see ink there, you would need to see a point there. So if there's ink there, there needs to be ink there, and there's not. So that is not a line of symmetry. This is a line of symmetry because there's ink there. You go straight to this dotted line, same distance over to the other side, there's ink there. You start there, go to the line, straight to the other side, there's ink there. So that means that that is a genuine line of symmetry, and that is a genuine line of symmetry as well, or an axis of symmetry. So what they want to know is how many it is that's got two. Okay? You need to check whether the diagonals are axes of symmetry as well. I don't think these are, because if I went straight to the line and then straight out the other side, I should see ink there, and I don't. Okay? So that's the first type, that's the most familiar type. The second so the other type is rotational symmetry. And the first time I heard about this, I didn't really think it was symmetry at all. But, you know, English is a living language. Words mean what people say they mean. So, what you have to do for this is you have to imagine how many times would it land on itself if you turned it round, if you rotated it. So, I think if we rotated it there, I'm just going to get some oven paper. Okay, so as I turn this, how many times does it land on itself? Okay, now it'll always land on itself at least twice, once at the beginning and once at the end. If they're the only times it lands on itself, you just say the answer is 0. So in other words, it has order of rotational symmetry 0. I always put a little line so I can remember how much I've turned it. Then you dig in. So it's not on top of itself at the moment. Still not on top of itself. And here we've got a point where it is on top of itself. So the answer is at least once. And I don't think it's going to be ever again. Okay, so in my full rotation, it was on top of itself at the beginning, on top of itself at the end, and once on the way round, which means your answer is 2. Okay, I know that seems a bit weird, but basically you either count the beginning or the end, but not both. So that's 1 on the way round plus 1 from either the beginning or the end. But remember what I said, if it never lands on itself on the way round, you just say the answer is 0. You don't say the answer is 1. So basically you never get an answer of 1. You either get answers of 0 to 4, 3, 5, etc. You never have an answer of 1.